Hello everyone. I am Shruti Rupa. I am InfoSec Girls Pune chapter lead. I also work under WAF research at Qualys. So today I'll be talking about the basics of blockchain. I'll be covering the basics in as simple as possible. I'll not get into too much technical details for the first video. I just want to give you an overview of what blockchain is so that for the next video, I'll get into the more technical details and we can understand it more. So let us begin. So we'll start with the basics of blockchain. Before that, who am I? I am a web application security analyst at Qualys. I am InfoSec Girls Pune chapter lead. I'm also one of the women who code lead in Pune. I'm an independent researcher and a blockchain and security enthusiast. So you can locate me at my Twitter handle freak_crypt, and also you can contact me through my LinkedIn profile. So you have, if you have any questions, you have any queries, any feedbacks that you would like to give me in related to this video, you can let me know. So let's start. So what is cryptocurrency? If we start with the very layman term, like we have a physical currency, right? We have cash, we have coins. So whenever you're making any transaction using cash or coin, something which is visible, like there's some transaction which is happening, right? You have some amount of money, say 100 rupees, out of which you're giving 50 rupees to somebody else. 50 rupees is deducted from your account, from your 100 rupees, and it is being given to the receiver. So there is some physical, you can, I mean to say, is it is visible that you're making a transaction. But in case of cryptocurrency, it is a virtual currency. Again, it also acts as a medium of exchange, and it uses strong cryptography for transactions. So it is a virtual currency, right? A digital currency. So it must be a piece of code. Then how are we confirming that a cryptocurrency, how are we confirming that if a transaction is being performed using a cryptocurrency is valid, is verified or not? And it is widely used, right? We all know how much cryptocurrencies are being used currently, right? Like bitcoins, there's more examples to it, like Bitcoin, Ethereum, more of Ether, Ripple, Bitcoin Cash, Litecoin, Darkcoin, and many. You have a kind of like unending number of cryptocurrencies that we have right now. Each of them are having their white papers, they have some other use cases, they are being used differently for different reasons, and there are so many. Like if you try to find out about different cryptocurrencies, you'll get to know about a lot and lot of them. But what do all cryptocurrencies have in common? Right, we all know, we are talking about the subject, right? Blockchain. So each and every cryptocurrency has a blockchain, and this blockchain is actually helping in verifying and validating a transaction using that cryptocurrency. How is it doing that? We'll get to know about it later. Let us have some simpler ideas, like how is it happening over here. So blockchain is just a chain of blocks. So you have certain blocks, each of them are linked. How are they linked? They are linked with the help of hashes. Why hashes? Because whenever you're making a transaction using a cryptocurrency, you need to have an integrity to be maintained. You need to make sure that nobody is ever able to tamper the data, right? So we use hashes for that, and we use strong cryptographic hashing algorithm, and the hash of each block is linked to its previous hash. So if you will get into the structure a bit later. So if you see the sum of the key points, it's better to know the key points first so that I can actually explain you the structure and how it is maintaining these key points using the structure. First of all, it is decentralized. There is, sorry, there is no central authority. There is no main authority or a central government which is taking care of any kind of transaction. So each and every node within the network, within the blockchain network, is itself taking care of it with the help. How is it doing it? We'll get to know about it. No worries. It is immutable. Immutable as in once in the blockchain, always in the blockchain. So once a data, once an information is stored in the block, within the blockchain, you cannot do anything with it. It is transparent, so every node within the network is able to see what is happening. It is anonymous. You can maintain your anonymity. You don't know which node it is, but you know it is transparent enough to be seen, like everybody knows what is happening within the blockchain. Distributed ledger. So it actually contains a record of all kinds of transactions, and it is distributed amongst each and every node within the network. So you are able to see it is transparent, it has records, it is immutable, you can maintain the anonymity, and it is decentralized. How is it actually doing it? So let's get into there are two structures. This is in more detail. This is one of the very simple one. Like there are many blocks in number of records you can see. Each of the records are the blocks, and they have some data. And as we can see that it is pointing towards this. This block is pointing towards this, and this is how each of them are pointing towards the next block. And this pointing thing which is happening, this linking, the way it is linked is through the hashes that I was talking about. So if you are trying to perform man in the middle, say over here, you have to tamper data of the previous block and keep on going to its previous block, heading back to the very first block ever created. So for performing such kind of attacks, you need to play with the entire blockchain from the very first blockchain, which is very first block, sorry, which is a very difficult thing to do, and nobody is going to attack in that way, right? You have to find some other alternatives, and we will be talking about that. No issues with that. So getting into the details of the structure, we'll be talking about Merkle root later. Let us first see how is it happening. So you have block 1 transactions, block 2 transactions, block 3 transactions. You have some other transactions also previously. So block 1, there is a hash of the previous block header. What does the hash contain? What does a block contain? The block contains some of the important information, like like if you have made a transaction, then the transaction ID you might be having, you might be having the timestamp. You need to maintain at what time the transaction was made. You might need to have the address, the public address. You might need to have the nonce. We'll be talking about what nonce is. Don't worry. These are some of the information that you need to be having, and the hash of such information, I mean, present in the block, whose the hash of the previous block header, whose hash is over here. This is how it is actually maintaining. It is not that the complete hash or complete detail is being stored in the next block of the blockchain. It is just the hash of the previous block header, because header is containing some of the important informations as well. We'll see what does a header contain, what does a body contain. Don't worry about that. How a blockchain looks like, we'll be seeing that too. Uh, so let's start. Let's go with the next slide. So evolution, this is the very important part that we need to know, and that this is what we'll be talking about in our upcoming videos as well. Like technically speaking, if you need to know about blockchain, you need to know about all these things. You need to know how a blockchain works, and on the basis of that you'll be able to understand how to make use of blockchain over here. So the very first evolution which was made was blockchain 1.0, where we were introduced to Bitcoin. And then we had so many cryptocurrencies. Like each and every cryptocurrencies had a blockchain. So whatever transaction you were making, its details, its information was stored in the blockchain. So this is the blockchain 1.0, was introduced by Satoshi Nakamoto in his Bitcoin white paper. Then came into picture blockchain 2.0. The person who wrote about smart contracts, Vitalik, he came up with a Ethereum-based platform where he had a thought like why blockchain should be used only for cryptocurrencies, for making just transactions and not for providing solutions to certain problems. Like smart contracts are nothing but just piece of code, and those piece of code are actually providing some solutions to problems. There's certain test cases which are being solved. We'll be talking about them, don't worry. But Ethereum based platform is the very first platform which came up with the smart contracts concept. Then blockchain 3.0, we have dApps. dApps are nothing but decentralized applications. So now you have an entire infrastructure, I mean an entire application with its front end, with its back end, and it has a blockchain behind. So whatever details you are having, you can store it in the blockchain. Also you can store it in another database. How you are actually connecting, you are linking the front end with the blockchain. You'll be introduced to Web3, you'll be introduced to Node.js. You must be knowing about Node.js, right? React.js, Node.js, how they are being used in blockchain. These are certain applications, how they're used in decentralized applications. So you have an entire application which is decentralized. There is no central authority for it. And currently we are into blockchain 4.0, where we are making use of blockchain in our industry. One simple example that I can give you is, like, suppose you have come to visit a doctor, you have come to a hospital, and all your records, all your information is already present. Suppose you are a very old patient, so it is quite difficult for a doctor or for the receptionist to find your details if you are a very old patient who has come for a checkup after many years, maybe, suppose if you have come. So at that time, your blockchain, if your details are present in the blockchain, if they're using an application which has blockchain, then your information will never be tampered. You know that your details are always there in blockchain. A patient's records are something which should never be lost, right? Which should never be tampered. So here there are certain examples where you can actually use blockchain. So now they are coming into picture into different industries, like different in health sector, in educational sectors, and in different sectors where you're actually using blockchain. I can show you some examples of how blockchain is being used. Like suppose this is Etherscan. As I told about a platform, Ethereum, here you have actual blocks over here. See the latest blocks that we have, the latest transactions. Each and every block has their latest transaction. So this is one block. This is one transaction where we can look into. So this is the block. You can see the block height. You can go to the previous block. whose height is this. There are 97 transactions. Since I was talking about smart contracts, Ethereum uses smart contracts. So they have some contract internal transactions. Who has mined it? We'll be talking about mining as well. In our next video, we'll be talking about miners, mining, proof of concept, how is actually blockchain verifying and validating all these transactions. So don't worry about it. We'll be getting into it. Difficulty level, what is the meaning of difficulty level, what is gas? These are something we'll be talking about later. You don't have to like think about it much. You have hash, parent hash, nonce that I was talking about. So these are certain informations which are present in the block, as we can see. We can also see the transaction. This is the transaction details. What does a transaction detail of an Ethereum-based blockchain has? It has a transaction hash. The status is success. So your transaction was successful. From, see, this is the address from whom the transaction has been made, to whom the transaction has been made. This is the value. This is the transaction fee, gas limit, everything that you can see. Okay, you must be logged in to use the private node feature. So this is just some basics. Also in Ethereum based blockchain, you can have these are certain tokens. You can you have different test cases, some testing environment also. For example, as I told that we have smart contracts which are just pieces of code. So for testing those code, we have some environment also. We'll be talking about them as well. So Ethereum has, like over here we have. Also we can look into Bitcoin transactions, like, wait. We can look into the blocks. So these are the latest blocks. Their size, the reward, how much time ago. This is the block hash. Pools, hash rate, rank. There's so many things over here. Bitcoin, btc.com, maybe for making transactions. So let's go to this block and see what are the details over here. Block hash, you have the hash of the previous block also. Merkle root, we need to know what Merkle root is for understanding blockchain. So no issues with that. So if you, as we saw one of the image where each of the block was linked to its previous block, you can see that this is one block and these are the transactions. See, this is one transaction. The transaction ID, this is one transaction. There's so many transactions within this one block. If you can go to this transaction, we'll get to know about more details. Input scripts and everything that we have. They have Ethereum also, Bitcoin hash. We can see the wallet. We have wallets also. Of course, we need to have wallets for making the transaction, right? So these are some of the details, some of the basic details of blockchain. And don't worry, we'll be talking about them in details, in more technical details in our later videos. I hope you got an overview of what blockchain is. Don't worry if you did not understand, let me know. Shoot up the questions, let me know what did you not understand. I'll be covering them in my next video as well. And thank you so much, InfoSec girls, for providing me this opportunity. So thank you. That's it. We'll see in the next video.